All right, this next one is also just a vertical problem, but now we're actually throwing it downward with an initial velocity that is not zero. So this is kind of like a dropping problem, but now that we have an initial velocity, it can change our approach a little bit. So we are now on top of a 100-meter building, and we have a water balloon, and we're throwing it downward at 10 meters per second. All right, so what are some things that we know about this? We know, again, because anything going vertical has the acceleration of negative 10 meters per second. We know that to be true. In the previous dropping problem, we knew that, oh, it's dropping, so it has an initial velocity of 0, but this time it does not. It has a 10 meters per second downward. I'll put that in red so you discovered that in the problem. And it's 10 meters, and it's downward. So this is where people get messed up on this problem, is we forget that down is negative. So that initial velocity is negative 10. So we need to make sure that we put that negative 10 in there. All right, we also know that it's going to drop 100 meters, and since it's dropping below us, we know that that is going to have a negative 100-meter displacement. So now, similar to the dropping problem, we need to solve for final velocity and time. All right, so now let's take a look at this and say, all right, you might just automatically assume, hey, let's just solve it the exact same way as the dropping problem. Cool. All right, so let's give it a shot. So we see that we do this. All right, so we got, my displacement is negative 100, my initial velocity is negative 10t plus 1/2 negative 10 times t squared. Uh-oh. This looks eerily like a quadratic. Now, while you could solve it, okay, since you may know how to use quadratic formula or other ways to do that, we will not, in this class, solve quadratic. So this is not going to get us what we want. So typically we solve for time first in a lot of situations, but we don't, all right? Just a reminder, this is a throwing down problem. All right, so we tried this, it didn't work. Well, I don't have final velocity and I don't have my time, so I can't use that. I can't use that. Now, this is one of those situations, and we don't do it often, where we use this equation. All right, so I have my final velocity squared equals my initial velocity squared plus 2a change in x. My initial velocity is negative 10 squared plus 2 times negative 10 times my displacement of negative 100 equals my velocity squared. So this equals 100, right? A negative squared, negative times a negative is a positive. Plus, we got a negative and negative again, which is going to make it positive. That's 1,000 times 2 is 2,000. So my final velocity squared equals 2,100. So I take the square root of both sides. And off the top of my head, I don't recall what it is. Let's see if I remember. All right, so the final velocity is 45.83 meters per second. Now, this is that other place where people can get mixed up on this problem. What direction is it going? Down. So when I use my final answer, even though this gives me a positive value, I have to know this actually, to be accurate, I have to put that negative in there, because that's the direction that it's going. Again, negative just tells me direction. All right, so that is the key on that one, is inserting that. So you got to insert that yourself. All right. Now we can go for time. And so now we can go for t, because we know how fast it's actually going. So we could just use this second equation. All right, so now that I have it as negative 45.83 equals negative 10 plus negative 10 times t, right, I add 10 to both sides. And this is that other place where people can get mixed up. And you realize this is getting bigger when the number is actually getting smaller, because it's a negative value. So it's 35, not 55, which a lot of people will just forget this negative and then add 10, it gets to 55. Right? It's not. It's a negative value because it's traveling downward, And we're going to also find that if it equals negative 10t, if I divide it by a negative when it was a positive, I get a negative time, which we can't get. So it means I missed a sign somewhere. Divide by negative 10 on both sides. All right, the negatives cancel. And then my time is 3.58 seconds. All right. So this is a good problem because there's a couple places where you can get a little mixed up if your signs are off. We also have to use one of these equations that we don't typically use. And so that's nice to work this into our equation solving now and again to remember how to use it. All right, we had to put in the negative value for our final answer because it's not given to us when we take the square root of a value. We're not going to have imaginary numbers in this as well. Making sure that we have the negative in displacements, we have the negative in initial velocity. Again, if you see negative, 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 everything's going downward. We're going to see on the next problem, when we throw something up in the air, that this initial velocity will be positive, and we'll see how that impacts our solving. All right. Any questions on these, please reach out.